Hi guys, welcome back to the CCNA training, and I hope you guys are doing well. So in the last session, we discussed how inter-VLAN works, right? We discussed how inter-VLAN routing is configured. So basically, we discussed about two methods. The first one was SVI, which is switched virtual interface. Then the next method which we discussed was ROAS. So ROAS stands for router owner's check. And inter-VLAN was all about making communication between devices of, let's say, one VLAN, VLAN 10, possible with the devices of some other VLAN, let's say VLAN 20. So inter-VLAN routing was all about making these devices communicate with each other. Now we are going to discuss about SGP, and SGP stands for Spanning Tree Protocol. So basically, Spanning Tree Protocol is something, and it uses a algorithm which is SGA and stands for Spanning Tree Algorithm. So Spanning Tree Protocol works on Spanning Tree algorithm only. Yes, Neeraj, this is a different topic, and this is about how we can avoid redundancy, or we can say avoid loop in a redundant network. So basically, when let's say you have a topology where you have this switch 1 which is connected to switch 2, and these are connected again with switch 3. So in a topology like this, what will happen whenever the switch 1 will broadcast, or let's say what we have learned about this, I mean we have already learned about the unknown unicast flooding. So whenever this flooding will occur, or let's say this flooding will happen in this topology, the packets will go from here to switch 2. Then switch 2 will again broadcast it to switch 3. Then similarly switch 3 will share some information with switch 1, and this will create a loop, and the info will reach switch 1 again, right? And if switch 2 also starts sharing, then this will create an endless loop of data transmission. Now to avoid this loop, we use a spanning tree protocol. And what happens when we use spanning tree protocol is one of the link gets down. So let's say this link between switch 2 and switch 3 gets down, and after that only switch 1 will be able to reach switch 2 over this link, and switch 3 over this link, right? Similarly, switch 3 will be able to reach switch 1 over this link, and switch 2 will be able to reach switch 1 over this link. So in order to avoid such loops, we use spanning tree protocol, and you can only observe spanning tree protocol in a redundant topology. So what I mean through this is, So you will not find spanning tree protocol in a topology like this. So let's say this is the switch 1 and it is connected to switch 2. Now after this, switch 2 is connected to switch 3. So there is no redundancy in this topology, right? So we'll not find spanning tree protocol in such topologies. You will see spanning tree in topology like this. Or let's say like this. So in such cases, you will be able to like observe the spanning tree protocol working. So now we will understand how this whole procedure goes within these switches and what exactly is spanning tree protocol. So there is a whole procedure when it comes to spanning tree. So this begins with the very first step, which is root bridge election. Now this root bridge election is done by exchanging BPDU. So we will discuss what exactly root bridge is and what are the functions of a root bridge in a topology. So basically, this election occurs between devices. So let's just take the previous topology only, and let's assume this is switch 1 and this is switch 2 and this is switch 3. So now the MAC address of switch 1 is 4 times 1 and 4 times 2 of switch 2, then 333 for switch 3. So now they will start exchanging BPDU, and BPDU is bridge protocol data unit. This is the message type which they will start exchanging between them to let's say discover or to make the spanning tree protocol process begin. Now this BPDU contains, so this BPDU contains bridge ID. Bridge ID. So what we are exactly learning here is out of these three switch, one switch is going to be a root bridge. So we are understanding how these switch elect that one switch, like how they decide that which switch is going to be the root bridge out of them. So we are learning that only. So they exchange BPDU and this BPDU contains bridge ID. Now if we talk about the distribution of bridge ID, then it is made up of priority value, and MAC address. And the size of priority value is, so the whole bridge ID is of 8 bytes, out of which priority value is of 2 bytes and the MAC address is of 6 bytes. Also, these are exchanged every 2 seconds. So BPDUs among these switches will be exchanged every 2 seconds, and default priority value is, so default priority value is 32768. So basically the switch with lowest priority value will be elected as root bridge, and let's say in this case the priority value of switch 1 is 32768, which is the default value, Similarly, on switch 2 as well, the priority value is 32768, again the default one. Then on switch 3, the priority value is 32768. Now, in such cases, the question arises, or the question might have already been there in your mind, that which switch will be elected as the root bridge. Since all of them have the same priority value, now we will consider the lowest MAC address to to elect the root bridge. So in this case, tell me that which switch will be elected as the root bridge out of these three. Since the priority value is same, we will consider the MAC address. Yes, exactly. So we have the answer switch 1 because it has the lowest MAC address. So I'm writing this as well, that if priority value is same or equal on devices, uh, lowest MAC will be considered. Make sense? You guys now, like, you must all be clear about how root bridge elections occur, right? Great. So when we look into this topology, we are like, now we are sure that switch 1 is going to be the root bridge, right? So let's name it as root bridge, and now all the ports of root bridge remains on. So let's assume this as FA0/1 and this one as 0/2. So this FA01 and FA02 will always be up. Let me clear this and write this up neatly. So we have this switch, which is switch 1 and is root bridge, right? Then we have this switch, switch 2, and these both are connected to another switch, switch 3. This is 0/1, this is 0/2. Then this is 0/1, 0/2. We have a MAC of 4 times 1, and for this we have 4 times 2, then we have 4 times 3. The first step of STP is election of root bridge, and we have learned how this works, right? They exchange BPDU every 2 seconds, and BPDU is made up of priority value and MAC address, and the lowest priority is always preferred. But when the devices are configured with same priority on all devices, so in that case, lowest MAC will be considered. And whatever bridge or whomsoever is elected as the root bridge of that bridge, all the ports will remain on. Now, this, so in this case, if we talk about this case, we have these three switch with same priority values, and the switch with lowest MAC, which was switch 1, is elected as root bridge, and both of the interfaces of switch 1, which is FA01 and FA02, will always be on and will remain up. Now this goes to the next step, which is root port election. Now we are going to elect the root port. So this is done on the basis of cost. And if we talk about the types of cost, we have the first cost as interface cost, then we have link cost, or you can say the path cost. And for interface cost, you can call it as port cost. So we in this example have assumed that these devices are connected over fast Ethernet cable, right? Or the fast Ethernet ports. So there are some default costs which are like calculated on the basis of bandwidth. So I am writing some of them. So interface cost of Ethernet is 100, then fast Ethernet is 19, then we have gigabit Ethernet, the cost is 4, then for 10 gigabit it is 2. So let's say a switch is connected with another switch, and this is on FA0/1, then here also we have FA0/1. Can I say that the cost to reach from switch 1 to switch number 2 using this link is 19? Can I say that? Yes, right? So what basically we are learning here is if we talk about the interface cost, then on switch 1 it is 19, right? And if we talk about the interface cost of switch 2, then again it is 19. And if we talk about this whole traveling cost, or let's say the data transmission cost, then if we talk about this cost, this is going to be called as path cost. Now let's assume that switch 2 is connected to another switch. Okay. Now let's assume that this switch 2 is being connected to switch 3, and this is FA0/2, but on switch 3 it is being connected on port gigabit Ethernet, so GE, let's say 0/1. Now the port cost on switch 2 for FA02 will be 19, right? And if we talk about switch 3, which is gigabit Ethernet 0/1, the port cost is going to be 4. Now the question is, what will be the cost, or what will we consider as a cost for data to be transmitted from switch 2 to switch 3? So in this case, when on the both of the ends we had fast Ethernet, we simply route 19 for the path cost, right? But in cases like these, when you have some different ports on the both of the end, you will consider the cost which is higher. So if we look into this, we know that 19 is greater, or 19 is more than 4, right? So we'll be considering 19 as the cost for this link. Do you guys understand how like link and interface costs are different and how this basically works? Makes sense to you guys? So I hope you all are clear with this. Okay, Pradeep is saying no. Tell me if you guys are also like not clear about this. I'll repeat myself. Not the lower one. Okay, let me just quickly repeat myself on this. So just tell me that you are clear about interface and link cost. You guys are like aware, or I would say, are you guys clear about these two different types of cost? Yes, great. So we took an example where this switch 1 was there and it was being connected to another switch 2. So I would request you to pay attention now and try understanding this as much as you can. So then after that we have another switch 3. So let's just take a simple example and assume that this Ethernet is being plugged on switch 1 on the port number FA01. Then on switch 2, it is FA01, and on this end, which is connecting to switch number 3, the cable is inserted in FA02. Then similarly on switch 3 we have FA01. If we look into this table, we know that the cost for fast Ethernet ports is 19, right? So can I say that the cost to travel from switch 1 to switch 2 will be 19? And is it clear to you guys till now? Yes. Okay. So let me know if you have doubt in this. Okay, great. Now, if I say that the traveling cost from switch number 1 to switch number 3 will be 38. Is it clear how this works? So how cost can be calculated? So 19 for this link, then again 19 for this link, right? Great. Simply we have just added the cost and we have the result of the total cost. Now what I am saying here is, now I want you guys to pay attention. Now I am saying that this cable was now inserted to gigabit Ethernet port instead of the fast Ethernet port. So it was inserted in GE0/1. And when we look at the cost of such ports, we know that it is 4, right? That's 4 for gigabit Ethernet. And similarly, if we look at on the other end, we are getting connected with fast Ethernet port and the cost here is 19. Now the question which comes to my mind is that what will be the cost to travel from switch 2 to switch 3? Shall we consider 4 or shall we consider 19? So the answer to this is that you just take the bigger one. Or you can say whatever the cost is greater on the ports, you will just take that. So we will consider 19 again. Make sense? And again the total cost will be 38. Now I want you guys to assume that this switch is totally connected over gigabit Ethernet ports. So let's say here also it was connected on GE0/1. Now we know that the cost will be 4, right? And if we talk about the traveling cost, it will be 8. So the total cost will end up to 27. That's how this works. I hope this is clear to you all now. And so this was something about cost, and now we will learn how this works on root port elections, how this is connected to root port elections. So basically, root port is the port of non-bridge, or I would say non-root bridge switch. So this port connects the non-bridge switch to the root bridge. So if we look into the diagram, we know that root bridge is switch 1, right? So root port is something which is there on non-root bridge switch. So tell me, oh, I made a mistake. Sorry, Vicky, that's 4 and this should be 23. You are right. And so guys, yeah, so that was a mistake. I'm sorry for that. And the traveling cost will be 4 on this end, and the total cost to travel from switch 1 to switch 3 is going to be 23. So you simply add 19 plus 4. Okay, so now the election of root port is being done for non-root bridge switches. So if we look into this example, tell me that which switch is not a root bridge switch. So out of these three, we know that switch 1 is a root bridge, right? So if we talk about switch 2 and switch 3, these two are non-root bridge switch, right? Now we can see that there are two ports on switch 2, which is FA02 and FA01, and similarly on switch 3 also we have FA02 and FA01. Now we are going to tell them that which port of these two is your root port. So we have just learned about cost, and you can say that whichever port is making the connection to root bridge with the lowest cost can be considered as um, root port. So in order to reach from switch 1, from switch 2 to switch 1, we have two options, right? The first one is from FA0/2, which goes from here and directly reaches to switch 1. And the other one is this, right? So I want you guys to answer this, that which path is with the lowest cost, or can I say that cost to reach switch 1 from switch 2 is 19, and from switch 2 to switch 3, then after that from switch 3 to switch 1 it is 38. Tell me that, am I right here? Is it true that the cost for this route, which is going from like this, is 38, then for this route it is 19? Yes, right? So basically we will select the path which is there with the lowest costs. So we are going to select this path, right? We will be selecting the path which is going there from FA02, and for the same reason we will elect it as root port. So I'm repeating myself. Root port is the port which connects the non-bridge switch, which is switch 2 and switch 3, with the root bridge, which is switch 1. And the port with the lowest cost is elected as root port. So if we talk about switch 2, the port which was there with the lowest cost was FA02, right? Because that was 19. And if we talk about the path from FA01, it costed us 38. So we'll select the lowest one and we'll elect it as root port. So that's how root port election works. Clear to you all? Is it like clear how election and cost works? So sure, Sonam, the root port is FA02 on switch number 2. Now we are going to talk about the root port of switch number 3. So if I say that FA02 on switch number 3 can be elected as root port, can I say that? Or shall we elect FA01 as the root port? Tell me. Which port should be the root port on switch number 3? FA02 or FA01? Great. So I can see everyone is telling me that FA02 should be the root port. And why? Because this is the nearest one, or we can say this will cost us the least, which is 19. If we talk about fast Ethernet ports. So FA02 will be a root port in this case. Now this was the second thing which occurs in the spanning tree protocol. Now we will move ahead. We'll understand how blocking or how things work ahead in the process. Okay. Here we go. Now this brings us to the third step, or the third part of the procedure, which is electing designated port. So all the ports of root bridge are designated ports. As I said before, that they will remain up all the time, and we can call them as designated port. Now, if we talk about the remaining ones, so we have FA01 and FA01 on the both of the ends, right? The FA02 of switch 2 and FA02 of switch 3 is already the root port, right? Now, out of these remaining ports, the port connecting to lowest MAC address will be considered as designated port. So, out of FA01 and FA01 of switch 2 and switch 3, tell me which port is getting connected to the lowest MAC address, or which port has the lowest MAC address? That's switch 2, right? So we are going to elect it as designated port. And when you are done with the election of designated port, the rest of the port, or if we talk particularly about this topology, the FA01 of switch 3, this port will be logged port. Makes sense? So basically, this port will remain down in a topology like this, and this will remain up. Now there is a specific reason behind this also. So let's assume that this link between switch 1 and switch 2 goes down. Let's say this goes down. So in that case, this port will inform the port of switch 3 which was down, or we can say which was blocked, that hey, there is a link which is down now, from which I was being connected to switch 1. I request you to make yourself up, or we can say to make the FA01 up, so that we can share the data ahead. And let's assume that this port also we block this port as well. So in such case, switch number 2 won't be able to like communicate with switch 3 about this link being down. So to avoid such cases, we are like keeping this as designated port, and it will remain always up, so that it can inform the switch number 3 about the link failure. Make sense? Okay, so basically designated ports are so first of all, the very first thing when we talk about designated port is that all the ports of root bridge which we have switch 1 are designated port. So we will quickly assume that FA01 and FA02 is going to be the designated port. Is it clear till now? So all the ports of root bridge are designated port. Now we are left with two ports, which is FA01 of switch number 2, then FA01 of switch number 3. Now out of these two ports, whatever port who is being connected to lowest MAC will be elected as the designated port. So in this case, we know that this MAC is the lowest out of the available MACs. Or if we compare the MACs of switch number 2 and switch number 3, we know that switch 2 is the one with the lesser MAC. So we will consider FA01 of switch 2 as the designated port, and FA01 of switch 3 will be the blocked port. So basically the fourth step is remaining port the remaining port is the blocked one. I hope it is clear, yeah, clear to you all. Let me know if you still have doubt. So Abhijit, Pradeep, let me know if you still have doubt. Yes, you can say that. Hassan, that's also fine. So that's for your basic on understanding. You can consider it, but at the same time, make sure that that it will not work always, since we have the designated port on switch 1 as well, right? And if we look at the opposite port of that, that's root port. So designated port is simple that no, switch 3 has one port as FA02, which was earlier elected as a root port, right? Now, if we talk about FA01, that's the blocked port. So let's understand this again quickly. So someone has asked that whether this both of the ports of switch 2 are blocked ports or not. So if we block this port as well and this one also, so tell me that how switch 1 will be reaching to switch 3. Is there any chance to reach switch 3? So even if switch 2 tries to communicate, this port is blocked, right? So what exactly we have done here is, or we can say what exactly STP do is, they block one port in a topology, and that is done to basically avoid the loop of data transmission. So in this case, we blocked FA01, this port. So okay, so we have here, we have blocked this port. And how, like, I hope you guys are clear till root port election. Yes, okay. So I'm repeating myself after that. Please pay your attention on the class and the diagram. I hope you will be able to understand this now. So these switches were connected with each other, and this was root bridge. And since root port is only elected on non-root bridges, we know that this port will be elected as root port, and on this switch, this port will be elected as root port. Why? Because they are the one with the lowest cost to reach the root bridge. Right now, we are left with election of designated port. So the very first thing when we talk about designated port is that all the ports of root bridge are designated port. Now, if we look into the topology, we are just left with this port, which is FA01, and this port, which is again FA01 of switch 3. Now, between these two, the port which is connected to a lowest MAC address will be elected as designated port. So switch 2 had the MAC of 2222, then 3333 for switch 3. Now if we look, that FA01 is the port which is getting connected to the lowest MAC. So we will like understand that this port will be designated port out of these two, right? So don't worry, we will understand this with another example of 4 switches. So tell me that is it clear till now how we like designated port? Yes or no? Yes, great, awesome. So now, since we are left with just this port, we will consider it as the block port. I hope it is clear how this works. Clear, right? Awesome. Now there are a few other things to keep in mind, and let's understand them. So we discussed that whichever switch has the lowest priority value will be considered as root port, right? At the very first election, which is the root port election. Oh, I'm sorry, the root bridge election. So the switch with the lowest priority will be considered as the root bridge. We will look into that as well, how this works. We will have a practical on that. Don't worry. No, that's not possible. Uh, so Vicky has asked that if we can observe spanning tree protocol with two switches or two devices. So that's not gonna create any loop, right? So now if we talk about root bridge elections, we discussed that the first thing which we keep in mind is lowest priority, and the default priority is 32768 of any switch. Then in case if the priority on all the devices are same, we will consider lowest MAC address to elect the root bridge. Now you can change the priority of a switch using some configurations, but you have to keep in mind that priority value can only be changed in multiples of 4096. So basically you can set a priority of 4096 or 8192 and so 12,288 and so on. It will go until 61 something. We will look into that once we are on the practical. But you have to like always put a priority which is a multiple of 4096. So that's something you have to keep in mind while assigning any priority to the switch. Make sense? That's something you have to keep in mind. So now you must have observed that once you connect a device with a switch, or let's say once you connect two switches together, the port takes some time to turn up and green, right? So there are some procedures, some timers which goes on, which like which occurs. Some processing is done on the ends to make the ports up, and we are going to like learn about these timers. So we call it as SGP port timers, and the very first thing is disabled. When the port is down, it is in this state, disabled. Then we have the second one as listening. So once the ports are up, so basically when the port is down, you can observe a red color there. And once the ports are up, you can observe a amber color there. So when you see amber color, you can assume that the port is in listening mode, or the listening status is the port has the status of listening. Then after that, you move ahead with these and you get into the learning mode. Then you can again, yeah, and this time also you will observe an amber color. So it takes 15 seconds to make port move from listening mode to the learning mode. Then after that, finally you reach the forwarding mode, and you can say it as FWD. Then again from learning to reach the forwarding mode, it takes 15 seconds. And here you can observe an green color. Then if we talk about blocking state, that's again there with the red color, right? A block port is of red color. So we will observe all this on the packet tracer. But as of now, you can understand that this is something when port is down, right? Disabled mode. Then after that we have listening mode. Now in the listening mode, it can only participate in if we talk about number 2, which is the listening mode, it can only participate in root bridge election, which was the very first thing of HTTP, and cannot learn MAC address. Until the port is in listening mode, it can only participate in root bridge election and cannot learn about MAC addresses. Then after that, if we talk about the learning mode, then here it can participate in root bridge election and can also create MAC table. Now if we talk about the fourth mode, which is forwarding, so here it can participate in root bridge election and along with that create the MAC table. Also it can now forward the traffic, so can forward traffic as well. So I hope you guys are now clear. So basically we can call it as, instead of timers, we can call it as SGP port states. So the state 1 is disabled, then we have learning, listening, forwarding and blocking. So I hope you guys are clear about the functioning of these states and we are good to go. So we will now move to packet tracer and we will understand how SGP can be observed with switches. If we go to switch, place out 3 switches and connect them together. Now we can see that all of the ports are in listening or learning mode, right? Hassan, I will tell you SGP with 4 switches as well. Please let's understand this with this topology only. And we can see that all the ports are in amber color. So basically either they are in listening mode or the learning mode. Now if we press this fast forward button, and now the ports are green, which means they are in forwarding mode, right? But if you look at FA02 of switch 2, it is still down. Why? Because of SGP. So basically SGP is not something which we configure. It is already there on the switches and we have just learned about the functioning of SGP. So this port is still down because of SGP. So we can assume it as the blocked port, right? So if we go to CLI of switch number 0, enable conf t, change the name to switch 1 and say show spanning tree. Once you press enter, it gives you some information about spanning tree, which says that root ID. So basically this information is about the root bridge, and bridge ID and all this information is about the local switch which we are currently in. So it says that priority is 32769, and why it is showing 9 instead of 768? Because this value is 32768 plus the VLAN number. So that sums up to 32769. Then after that, it says that a root bridge is there with a MAC address of this value. The cost to reach the root bridge is 19, and the port which is connecting this switch to root bridge is FA01. So basically, this is the port which is connecting switch 0 with the root bridge. Now, after that, there are information about timers. Then if we move ahead, we have the information about the local switch. So on this switch, which is switch 0, the priority is again 32769. The address, the MAC address of this switch is 0010 and this value. Again, it is telling you about the timers. Then we have something called as aging time, which is there of 20 seconds. So basically, if we so I told you before that they share or they exchange BPDU every 2 seconds. So in case this switch doesn't receive the BPDU for 20 seconds, it will make this block port as green and it will start forwarding traffic over here. So what I am trying to say here is, so let's say if this switch doesn't receive BPDU on this port and for 20 seconds. So in that case, what will happen is the switch will assume this port as down or this link as down and will make this as up to keep the data transmission continue. Then we have FA01 as our root port, right? Because that's helping us to reach the root bridge. FA01 of switch 0 is root port. Then we have FA02 as designated port. Then they are in the state of forwarding. If you see, then the cost is 19 and you can like ignore this part as of now. That's not something which we are going to discuss about. So I hope it is clear how things work when it comes to STP. Now we will move to switch 1, CLI. Then we will look into the root bridge information on this switch. And let's see if it is same with the local switch. We go to show spanning tree. And once we look into the information, we can see that address of root bridge is 00C and something something. Then after that, when you look at the address of local switch, that's also again same as the address of root bridge, right? Why? Because this switch itself is the root bridge switch. Now, if we look into the roles of the ports, we know that all the ports are designated port, right? So FA01 and FA02 both have a role of designated port. Both are in state of forwarding and the cost is again same 19. Why? Because they are in fast Ethernet port. Now, if we look into this on switch number 2, we say enable conf t. Okay. So tree, and you will see that again there are two ports, FA01 and FA02. FA01 is the root port which is connecting switch 2 to the root bridge, right? So this is the port which is connecting it to the root bridge. Then after that we have FA02 as alternative and the state is blocked. So if we look into this, that will remain like this only and it will not be used to share traffic. So that was all about spanning tree. Now let's take an example of 4 switches as well to make you guys understand this more clearly. So we are going to take switch 1, then another switch here, switch 2, then we have switch 3 and a switch 4. So we have a question here. Before we move ahead, let's make this clear. So what if the connection from switch 2 disconnects and is a blocking port from switch 3 becomes the designated port? So let's try the same. And if we go to this switch and go to quantity interface FA0/1. So FA0/1 was being used to reach the root bridge, right? Now we will say it as shutdown. Now if we press the forward button, you can see that this port is up now because that's the only way to reach switch 1, right? Because this port is down. Make sense? So you guys can try this out. I will give you time, don't worry. And during that time, you can try all your doubts on the practical only and can observe the results out of them. So that will help you more instead of me telling you about them. So I'll give you time to try this out, don't worry. But before that, let's look into this topology and understand how this will work. So we are going to assume uh, the MAC address of these devices as 4111, then 4 times 2, then 3333, then again 4444. The priority value is going to be 32768 for switch 1, then 8192 for switch 2, then for switch 4 it will be again the default one 32768, and on switch 3 as well. Let's check the default only. So tell me that which switch out of these will be the root bridge. Yes, Vicky, if you change the priority value after the election, that will like the process will go again and will select the root bridge accordingly, and ports will change their state in the same way. So we have the answers, and some are saying switch 1 and some are saying switch 2. So guys, try to understand that the very first thing, the first thing to elect root bridge is lowest priority. In case the priority on all devices are same, then we will move ahead to lowest MAC address. Now, if we look at these devices, we have switch 2 as the device with lowest priority, right? We have a priority of 8192 on this device. So for the same reason, switch 2 will be the one which is going to be root bridge, right? In case switch 2 also had the priority value 32768, in that case, switch 1, we will select switch 1 as the root bridge because of the lowest MAC address. So since the priority value of switch 2 is lowest out of these 4 switches, we will elect it as root bridge. Make sense? And since this is a root bridge, we can say that this port is designated port, and which is, let's say, 01 and 02. This port also is a designated port. Clear till now? Now we will move ahead towards the election of root port. So we know all non-bridge will have the root port, right? So for switch 1, tell me which port out of 01 and 02 will be the root port.